Welcome back for some more normal distribution. This is basically covering section 6.2, but it kind of did 6.1 and 6.2 at the same time, just not quite in the same order as the book. So remember our example about the female grizzly bears and their weights being normally distributed with a mean of 350 and a standard deviation of 50? Well, we used the empirical rule in the previous video to find out about some probabilities or percentages. But what if we want to know about those things that don't fall in nice standard deviation boundaries? Like, for example, what if we wanted to know what percentage of grizzly bears weigh between 360 and 415 pounds? Well, if we look at our graph, 360 is going to be about ish here, right? Okay, why is it not letting me draw up there? And 415 is here ish, right? Those are not on nice boundaries, and we could like ballpark the area, like maybe we can guess, but we can't really use the empirical rule to help us figure that out. So, what are we going to do? Well, luckily for all of you, you aren't doing this 30 years ago, and you didn't have to do a lot of work to look this up in a tedious table. It was really annoying. But now we can use Desmos. Desmos is great. And we're going to right now go to Desmos and figure out what percentage of grizzly bears weigh between 360 and 415 pounds. So let's escape out of this PowerPoint. No, I don't actually. And go to any web browser and open up Desmos. So you just go to desmos.com. I can even start again, desmos.com. Like that. And it will open to this, and you click, yeah, let's graphing calculator. And here we go. Now, Desmos is a very useful graphing calculator. I'm guessing some of you have used it before. We're going to use it for our normal distributions. So we're going to start here and put in a command, and the command we're going to use is called normal distribution. Normal dis, just like, and you put in your left parenthesis, and the first thing you're going to put in is your mean, which is 350 in this example, comma, your standard deviation, which is 50 in this example. So just like how we refer to it when we use the notation. And we do want to use the cumulative probability distribution, so we want to have it summing up in between. And we click yes. And we'll worry about these in just a second. But right now it says if you go from negative infinity to infinity and you add them all up, you get 100%. So that's good. Now, looking at this graph, it's not very useful, but that's because we need to adjust the window. And this is most of the time in Desmos, you can just scroll in and out to adjust. But I recommend for this application for normal distributions, we go ahead and just set the window to what we want it to be. So click on the graph settings little wrench. And for our x-axis, that is our weights. And remember, the middle one's going to be 350. And 3 standard deviations below 350 is going to be 300, 250, 200. So I'm going to go maybe like just a smidge below that, like 150. And then a few standard deviations above 350, 400, 450, 500, maybe go 4 above. And that's what I want to set my x to be. I still don't see anything because my y-axis was way too big. So I'm going to put in negative 0.01 for my min. And I'm just going to put in 0.5 for my max and see what we get. Okay, you can see it's way down there. We can probably zoom in quite a bit on that. Let's do 0.3 instead of 3 and 0.18. So it does take a little bit of playing around, but these numbers are going to be very small. So there's our normal curve. It looks pretty nice. I'm pretty happy with that, actually. All right. And our question was, what was our question? I already forgot. The question was, what percentage of grizzly bears weigh between 360 and 415 pounds? So we're going to go over here to min and make that 360. And our max, I already forgot what the number was, 415. And there it's shaded in for you exactly the amount of area that it's calculating. It's starting at 360 and going to 415. Our scale on the x-axis here is 10, so you can see that. The area of this shaded region is colored in, is given to you in this number right here, all right? So the probability for a normal distribution with mean 350 and standard deviation 50 of being between 360 and 415 is 0.3239, blah, 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 all right? Let's go back to our PowerPoint here. We're going to be going back and forth quite a bit. All right. So again, to review what we did, we went to Desmos. We typed in normal dist with our mean and our standard deviation. We put in our min and max values, and we get our probability of 0.3239. So if I want to know what percentage, oh, this is still the old question. Sorry, this should be, oops, sorry. Oh my gosh, things have gone awry. See what percentage. I didn't change this slide, sorry. What percentage of grizzly bears weigh between 360 and 415? We'll change this to a percent by moving my decimal place twice, and I get 32.39%. And 2 decimals, why not? So about a third of the grizzly bears weigh between 360 and 415 pounds. Let's try another example. All right, let's suppose that the incubation period, that is the time between being infected with the virus and showing symptoms, for the Ebola virus is normally distributed with a mean of 12 and a standard deviation of 4.5 days. Let's find the probability that a randomly selected case demonstrates symptoms in fewer than 7 days. So anywhere from 0 days to 7 days. Let's go to Desmos and have it help us with this one also. So this one, the mean is 12 and the standard deviation is 4.5. Going to Desmos, mean is 12 and the standard deviation is 4.5, I hope, because I don't remember. Yep. All right, again, now our graph went away because we have our means way out here at 350. We need to go back and check the x-axis to be between 12 and 4.5, right? So let's go to like 0 and then maybe like max value of like, I don't know, 20. Okay, see how that got it. Well, we can scroll a bit. This is not too bad. Scroll in. So as long as you get a picture of it pretty good, you can scroll a bit to help you. All right. And now for this one, we wanted to know the probability that the symptoms would show up in 7 days or less. Let's make sure I got that question right. Find the probability that a randomly selected case demonstrates symptoms in fewer than 7 days. Okay, so less than 7. So my min is going to be 0, and my max is going to be 7, because remember, for all continuous probability distributions, the individual point doesn't have any probability. So this gets me right up to 7. And there's my probability, 0.1294. So that's my answer for this question. I plugged it in from 0 to 7. What is the probability? The probability is 0.1294, approximately 0.1294. So pretty straightforward, pretty easy to use. Let's try another example. All right, the cones in the eye detect light. The absorption rate of cones is normally distributed. In particular, the green cones have a mean of 535 nanometers and a standard deviation of 65 nanometers. If an incoming ray of light has wavelengths between 550 and 575 nanometers, calculate the percentage of that ray of light that will be absorbed by the green cones. This one's a little bit more complicated setup, but I think we can safely say that this is normally distributed with a mean of 535 and a standard deviation of 65. We want to find the probability or the percentage that this gives you that's the absorption amount. The absorption rate is normally distributed. Mean of 535, standard deviation is 65. And we want to know the absorption rate between 550 and 575 nanometers. So I would like you to pause the video right now, go to Desmos, put in between 550 and 575, and see if you can finish this problem. Pause the video, give it a try. All right, are you back? Let's give this a try. All right, so it was this time normally distributed. I always forget these numbers, but I think it's 535 and 65. And again, I don't see anything on my screen. 535, 65, because I need to adjust the window. So I'm not going to mess too much with the Y to start out with. I'm just going to go to the X, and I'm going to go from like 350 to like 700 and see how that goes. You know, a few standard deviations around each, and that doesn't look too bad. I can zoom in this one, and maybe I want a little less Y min. Let's drop that down to 0.001, and a little less Y max. So that's pretty good. Sometimes you just gotta kind of play with it until you see what you like. Oh, there we go. Normally distributed, mean of 535, standard deviation of 65, and we want to know the percentage of light absorbed for between 550 and 575. 550 and 575. All right, perfect. 0.1395966, and we go to the next page. I think I have this actually written down. So it's exactly what we have here. Oops, sorry. And that's going to be like 13.96%. All right, one more story problem. Let's talk about Girl Scout cookies. Girl Scout cookie Thin Mints have a standard size of 0.25 ounces, a mean size of 0.25 ounces, and a standard deviation of 0.03 of an ounce. Find the probability that one randomly selected cookie has a size of either more than 0.27 ounces or less than 0.21 ounces. All right, let's go ahead and see if Desmos can help us with this. So the mean is 0.25 and the standard deviation is 0.03. 0.25, 0.03. And again, let's just set these back to negative infinity and infinity. You don't have to do this, but I just wanted to show you guys that you can just type in infinity and that will reset. Oh, if I can spell it right. And that will reset the boundaries. Okay, now it's not showing anything because I need to adjust my scale. This is going to be really small. Let's go negative, or let's go 0.1 to 0.4. See how that turns out. Oh, I put 20.1 somehow. I have a 2 there. That's my trick. All right, since this is a much smaller number for my standard deviation, my scale on my y-axis is much larger. I think I'm just going to go through and bump this up to like 0.4 and see how that goes. Nope. Let's go up to 0.8. Let's go up to 0.9. It's such a small scaled problem. There we go. So the reason we can be up here with an output value of 13 is because the width down here is like 2/10 or 1/10. So still this area in here is still only equal to one whole. All right, now this one wanted to know the probability that one randomly selected cookie has a size of either more than 0.27 or less than 0.21. So let's go from 0.27 to infinity, 0.27. That's 1/2 of the probability. And now we can just duplicate this. I'm sure there's a faster way to duplicate this, but I don't know what it is. And cumulative. And then now we're going to go, oops, I didn't want to do that. We want to go from minus infinity up to the small value, which is 0.21. All right, so the red represents the probability that the cookie is bigger than 0.27 ounces, and the blue represents the probability that the cookie is less than 0.21. Together, those are mutually exclusive events. So together, the probability will be the sum of those two guys. So if we add them together, which I will do with my calculator right here. So we take 0.09, 0.0912 plus 0.2524. Is that the same number of decimal places? Yes. 252. We get 0.3436. Oh, I should have gone 2525. I didn't round correctly. We get 7343. That's my final answer. 0.3437 because I actually initially had not rounded that correctly.